Welcome to solverfy.
Alright, so here for my variables, I'm going to let x be equal to my kilograms of corn, y be equal to my tankage, and z be my kilograms of alfalfa. Then we want to figure out our objective. Our objective we see is to minimize our function, 84x plus 72y plus 60z. Then we have some nutritional requirements for our constraints. For our carbs, we have that 90x plus 20y plus 40z has to be greater than or equal to 200. For protein, 30x plus 80y plus 60z has to be greater than or equal to 180. And for vitamins, 10x plus 20y plus 60z has to be greater than or equal to 150. And then we also have our non-negativity, so x, y, and z have to be greater than 0. Then B, to have at least or at most 2 types in the mix, we can introduce our binary variables. I'm going to say that A, B, and C, where y of I is equal to 1 if feed type I is used in the mix, and y is equal to 0 otherwise. We need to make our new constraints. That's going to be that A plus B plus C is less than or equal to 2x, which is less than or equal to m of A times z, which is greater than or equal to our mix of B plus z, which is greater than or equal to our mix of z, where m is a large constant. Then we can introduce another binary variable, and when we do that, I'm going to call that binary variable z1, z2, and z3. Then our new constraints is going to be that z1 plus z2 plus z3 has to equal 2 times 90x plus 20y plus 40z, and that has to be greater than or equal to 200z1, 30x plus 80y plus 60z. And then we can substitute all this in to give our minimized cost while satisfying our requirement.